This is Unit 2, Section 4, but also I'm going to show you how to find the table on this calculator, the TI-84. First thing, of course, turn it on. Okay, then we go up here to y equals, and we put in whatever formula we want to. The first formula we're going to have is x squared minus 4. So I go x, which is right there, the second button down, and then I put a squared minus 4. Whoops, minus 4. Okay. Then I go over to the graph button at the top right hand side, hit graph. This graphs our equation. And then I hit the second button and table. Then with your up and down arrows you can have this thing showing all the points within 1 unit, 1 unit increments for your x's, and then over on the right is your y coordinates. That is how you get to the table on this calculator, and this is how you graph on this calculator. Okay, and second. Okay, Unit 2, Section 4 is graphing. Identify each equation, put into standard form, give the x and y intercepts unless they're lines. If they're lines, give the slope and the y-intercept, and also if they're parabolas, give the vertex, and give a table, which is very handy with your calculator, and graph. Number 1 is right here. Notice it's a parabola. Then the x-intercept is 2, 0, negative 2, 0 by factoring that. The y-intercept, put 0 in for the x, get your y coordinate. Then make your table. That's quite easy if you have the calculator. Then negative b over 2a, 0 over 2. So that gives you 0, negative 4, which is your first point on your vertex. First point that you use on your table. Very important on parabolas to have that vertex. Second one, y equals x squared plus 6x plus 8. Notice everything. Notice all the work I went through to tell you how to do this. Okay, remember you can pause this and look at this. Number 3, to get it into standard form, first thing you've got to do is y's got to be by itself when it's in standard form. Okay, it's a parabola. Up, it's a parabola because it's x squared. Okay, and up, because we look at this second equation here, we get the y to the other side where it's positive. X squared's positive, so that means the parabola opens up. Then I find my x-intercept by putting 0 in for the y, factoring. My y-intercept by putting 0 in for x. My vertex by using negative b over 2a. My table, I use that vertex first. 5, negative 4, then other values you can find with the calculator, or you can find them by doing by hand. X plus 2y equals 4. Number 4 is a line. Get the y by itself as I've shown here. Find your x-intercept, your y-intercept, your slope, draw your line. Number 5, y equals 4x squared minus 4x minus 3 is of course a parabola opening up because it's positive. And then in standard form is like this. I factored it. When you set it equal to 0, you can either factor parabolas or use the quadratic formula. But I factored it. 3 halves and negative 1 half. Y-intercept, put 0 in for x. Vertex, use negative b over 2a from up here. And that's 1 half negative 4. Then make your table using the vertex first, then go both sides of the vertex. Here's your parabola. Number 6, we've got to first get rid of the parentheses. So 4x squared minus 12x minus y equals negative 5. Then 4x squared minus 12x plus 5 equals y. You've got to make sure the y is positive by itself to get it in standard form. It's a parabola opening up because positive 4x squared. Then you could either factor that, which I've done here, to find the x-intercepts, or the quadratic formula. Y-intercept, 0, 5. Then your vertex is by taking negative of negative 12, 12 over 8, and reducing, 3 over 2, and working it out. Using that vertex first as your first point, because that vertex is very important, and then other points on each side of it. Number 7, x squared minus 1 equals plus y equals 0. So we've got to make the y positive, move the x squared to the other side, negative x squared plus 1. So that's a parabola opening down. Then put 0 in, factor, find your x-intercepts, put 0 in for your x-coordinate, find your y-intercept, 0, 1. Then your vertex is negative b over 2a. So b, there's no b up here, so 0, 1. Then use that vertex first, then go on each side of it. Number 8, okay, 9x squared plus 3x minus 20 plus y equals 0. So the 9x squared, the 3x, and the minus 20 need to move to the other side because y has got to be by itself. So we have it like here. Then I moved everything from the right side to the left side when I made it equal to 0 so that it was a positive 9x squared. Then I factored. Of course, you could have used the quadratic formula. 3x minus 4 and 3x plus 5. Then your y-intercept, put 0 in for x. Your vertex, negative b over 2a. This one was a little bit challenging. It was negative 1/6. So I used a calculator. 20 and 1/4. That is your vertex. Then I didn't use any fractions on the rest of my points. I could have just went with the calculator. Then here's a rough graph of this. Number 9, 2x minus 3y equals 9. A line. The work is shown there. Number 10, parabola. Y minus x squared equals 2 times x minus 1. We've got to work through this. So the x squared is going to move to the other side. Then we get rid of the parentheses also. So x squared plus 2x minus 2. Then I set it equal to 0. This one was not factorable. Had to use a quadratic formula. And so we found these two x-intercepts. Then I put 0 in for the x, 0, negative 2. Vertex, again, negative b over 2a for the x-coordinate. So we get negative 1, put that negative 1 back in, find the y-coordinate. So here's my points I used on my graph over here. Number 11, x squared minus 5x plus 4 plus y equals 0. Again, y's got to be by itself. Move the others to the other side. Then, okay, I put 0 equal to that. And then I moved all of that to the left side to change the signs. And then I factored, or you could have used a quadratic formula. X-intercepts, 4 and 1. Y-intercept, 0, negative 4. Then I used negative b over 2a. So 5 halves. 9/4 is the vertex. That's the first thing I used. Then I either used a calculator or I found my x values on either side of this 2.5 here and found ordered pairs here so I could graph it. Number 12, my graph looks pretty terrible here, but 24x plus y equals 9x squared. you've got to make it y equals 9x squared minus 24x plus 7, and then you either factor that, which I've done, or quadratic formula to find the x-intercepts, 7/3 and 1/3. Y-intercept, put 0 in for the x in the original equation, in the standard equation, 0, 7. Then negative b over 2a comes out to 24 over 18. Reduce to 4/3. At first I didn't reduce very well, but 4/3, negative 9. Then find your points, and then 4/3, negative 9 is important, your vertex, but after that I get points on either side of that 1 1/3, and I used integers, which I could have used from the calculator. And then my graph should be look much more like a parabola. Sorry, it's bad looking. 13. Y plus x squared minus 25. Again, y's got to be by itself, so it's negative x squared. So parabola opening down. X-intercept, I could factor that, or quadratic formula. X minus 5, x plus 5, so 5 is 0 and negative 5 0. Y-intercept, put 0 in for the x. Vertex, negative b over 2a, so there's no b, so it's 0. 0, 25. So rough graph here. Then 14, x minus 2, quantity squared. In standard form, x minus 2 times x minus 2 comes out to x squared minus 4x plus 4. Then 0 equaled that x minus 2 quantity squared. So 2 zeros your x-intercept, 0, 4 is your y-intercept, and 2, 0 your vertex. And then put those and find your point. 15, okay, is a line, but I multiplied by 6 first. Got 2y minus 3x equals negative 6. Then get the y by itself. Took a couple steps. My slope is 3/2. My y-intercept, 0, negative 3. The remaining problems I will put on another